Hello everybody, Chris here, and in this video I want to show you how you can have a player character interact with other objects inside of your Godot game project by having an area 2D, a region, where within that region it'll pick up on interactable objects inside of that region, and then you can press an interact action key in order to trigger the interaction function in these other objects, such as a fan to turn on the fan. And over here, we'll have a shop. We'll be able to open up this shop user interface and recognize that the player is the one who pressed the shop. And then we can check on how much money the player happens to have. So let's show where we're at so far. We have a player character with the standard default character body 2D movement template. So that means you can move left and right. And you can also press spacebar to jump. So to move left and right, you'd be doing left arrow, right arrow. And that's just the basic default script. I don't think I've changed anything else on it. Then over here, we have a fan object, which I haven't really set up yet, so that's just kind of sitting there. And then attached to this frog is a shop interface. So when we talk to the shop, it's going to open up this interface. You can see I already put in a close menu button, but we'll have it show the player and other stuff later on. And then in the top left, we have a label for showing how much money the player does. Currently, it doesn't do anything. It's just showing some standard default text. So let's start working on the interaction of the player. So on the player scene, I'm going to add a new node, and then I'm going to code in the interaction functions. So in the player scene, let's add a area 2D as a child of the player. So I'm going to right click, add child node, and let's look for area 2D. I'm going to rename this area 2D to be, let's say, interaction area, and we could say 2D if we want to specify that. And then I'm going to attach a script to this area 2D. Let's right click, attach a script. So this will go, I suppose, under player interaction area 2D, because it's going to rely on pressing an action, which means the player is controlling it. So it makes sense to put under the player category. So let's do interaction underscore area underscore 2D.gd, and this will inherit from area 2D. Before we start scripting, let's attach a collision shape 2D to the interaction area. So I want to right click here, add a child node, collision shape 2D. And in this collision shape 2D, we need to give it a shape resource. So over on the right, I'm going to click on the dropdown and do new circle shape. And then let's just expand this to be however big we want the area where we can interact to be. I'll also hit Q, and I'll move it down a little bit to center it a little bit more on the lower part of the player so that it kind of makes more sense with the sprite. So let's save that. We can take a look at the level scene and see our interaction area to kind of get an idea of anything within this area that's an interactable we'll be able to interact with. So maybe I'm going to move it 1 or 2 pixels back upwards and check the level scene again, and that looks pretty good. So in the interaction area script, and you can click right here to get back to it, we want to reference the character that is doing the interaction. So I'm going to do a @export var, and the variable name can be, let's say, interactor, as in the character doing the interaction. And we'll say any node 2D is acceptable for this, as long as it's some kind of 2D character, whether or not it has a character body. We're probably okay with assigning that here. But if you want to be more specific, you could say character body 2D, and then you'd only be able to assign this root player node. I'll leave it as node 2D for now to be a little bit more flexible. Okay, and then we need a interaction action, as in a key that we press on our keyboard or our input device, which triggers interacting with any nearby interactable nodes. So let's say @export var interaction action. This will be a string name, and I'll default it to interact. Okay, so if I save the script now, we can click on interaction area, and we can see our variables that can be assigned in the inspector over here now. So for our interactor, we want to assign the player script. So the character that is interacting is the player. And then the interaction action, this is just a string name right now. So we need to go into project settings, input map, and add a new action. I will call this interact, add, and then we need to assign a key for our interaction. So this can be any key you want. To add a key, press here, and then press the input on your input device. So I'm going to press F, and I'll just assign that. So this means my interaction key is F on the keyboard. You can also assign gameplay controller buttons if you need to, and you can have multiple keys for one action. So let's close that, and then we're going to need a function input. So we're going to do function underscore input, which gives us an event. If you want, you can add the optional type here of input event. So this is a input event, but if we add this here, it becomes more obvious that that's what we're dealing with. optional, of course. So we're going to say if event.is action pressed, and then we need to pass in the interaction action. So I'm going to use the variable up here rather than the string directly. So interaction underscore action. So if interaction action is pressed, which in this case is F on the keyboard, then we're going to tell the nearby interactable, if one exists, that we're trying to interact with it. So we need to know which object we're interacting with. So I'll have a variable up here. This one's not exported because we're not assigning it in the inspector. And this is going to be var selected interactable. And so we're going to take this down here and we'll say selected interactable dot interact. And then we're going to assign the interactor as a parameter. So that's interactor, and it should actually be a O, not a E. So let me just spell check that and correct it. So interactor gets assigned here as the parameter. Now, the selected interactable hasn't been assigned. We haven't created the interact method on it. So we can check if it's null first. So if selected interactable does not equal null, then we'll try to interact with it. That's just a check in the case that we don't have one. Then we don't want to try to interact with an object that doesn't exist. Okay, and let me paste the name there. 2 R's. So let's come back to this in a minute, and let's go into the objects folder, and I'll create another script here. So create new script, and this will be interactable. Let's go into here, and I want to add at the top of the script a class name interactable. So when we give a script a class name like this, it becomes really easy to check if another object that has a node is actually using that node as an interactable object and not just a basic node. So in the other script, we can assign to the selected interactable variable that this is going to only hold interactable types. So the class name here should be the typing of the variable here. Then inside of this class, we need a function interact, and this is going to take a user, which we'll say is a node 2D. And then for this function, I'm going to push a warning that this is not implemented. And the reason I'm doing this is because what interact does is going to depend on the object that is being interacted with. So a fan is going to toggle the fan animation on and off, and then the shop is going to open a shop UI, which is completely different. So we need to define this individually for each object class that is going to be interactable. So we can just extend from this script, and then we override the interaction function with our actual interact code. So now that we have this basic class, let's go to the fan scene, and I'm going to attach a new script here as well. So I will call this fan.gd, and let's inherit from Interactable, which is the class name we just defined. And we can say inherits from Interactable just like this because we put the class name at the top too. Okay, so we're going to have our fan here. Let's create the script. And then we want to define interactable for fan. So I'm going to right click here, look up symbol, and I'll copy this into the new class. So let's get rid of this automatic code, and I'm going to paste in function interact user node 2D. So our user interacts with the fan, and what that means is that they pressed the fan switch. So we want to toggle the fan on and off. So let's have a export variable for the status of the fan. So we'll say export var is on, and let's default this to true. Now if we look at the fan script, we can see we have the fan is on, and we can use that to set the animations of the fan. So what we're going to do here, get rid of the push warning, and what we're going to say here is that is on equals not is on. So basically, we're just taking whatever the true false value of is on is, and we're reversing it with the not keyword and assigning that to is on. So we're toggling it on and off. Okay, in the 2D scene for the fan, I'm also going to reset the position of the sprite back to the base position up here. It should be centered there here. And then on the level, I'll change the position of the fan here as well and get it back to where it should be. So putting it back down here. And now you can see the sprite is positioned basically on top of the root node, which is usually what you want. So now we have this object over here, but in order for an area 2D to recognize that something entered it, we need to have this either be a body 2D or a area 2D. Okay, so in order for the player's area to recognize that a body or an area has entered this area, we'll need to have on these objects either an area 2D or a physics body 2D. Now, I don't want the fan and the shop to actually interact with physics in any way. I want them to be ignored and just be more of a trigger area. So that's when an area 2D makes sense instead. So on the fan scene, I'm actually going to add a area 2D as a child node here. So let's add a area 2D. And then I'm going to open up Interactable script. And I'm going to change extends node to extends area 2D. So I'll save that. And that means I need to move the script off from fan. So I'll remove the script there. And let's assign it to the area 2D. So I'm going to assign the fan GD to area 2D. And maybe it makes sense to actually rename fan.gd to fan interactable. So in a sense, we're turning this into more of a component part of the full fan scene, and it handles the interaction code for us. But we might have a different script attached to fan up here at the top. So to make it clear what this area 2D is, let's rename it fan interactable area. We could say 2D if we want to be as specific as possible. And then, of course, an area 2D, we're going to need to assign a collision shape 2D to it. So add child node, collision shape 2D, and we'll make this a circle as well. So that can just kind of be roughly like that, however big you want it to make. So if we save this scene, now if we go over to the level, in order for this to recognize this, they have to overlap. So as long as you're okay with this detection radius and this being the size of the detectable area, then we're good here. So let's go into player one more time, our interaction variable 2D, and then we need to connect to the signals that our area 2D has. So if we go to the inspector area on the right and do node, you can see that area 2D has a bunch of signals like body entered and body exited and area entered and area exited. So because we know that an interactable is now an area 2D, we only need to add in area entered, but you could also do area entered and body entered at the same time if you want. So on ready, we're going to connect to those signals. So area entered is the name of the signal. We're going to connect to that, and we're going to give it a new function to have as our callback when the signal is triggered. So that's going to be underscore on area entered. Then we make that function down here, function underscore on area entered. And you can see in the node section on the right that this gives us an area 2D. So that'll be our parameter, area colon area 2D. And so when an area enters this area, we want to check if it's interactable, and then we want to set our selected interactable. So if the area is interactable, and we're using the class name here to check that, then we can proceed with our code that we want to affect interactable areas. So we might have more than one interactable at a time. So let's also have an array of nearby interactables. So we'll say variable nearby interactables, and this is going to be an array of interactable. So when an area enters, we're going to push it onto the array. So nearby interactables dot push, we'll say push back, as in we add it to the back of the array, and that's going to be the area. Okay, and I'm getting an error up here because the interactable here has one R, which is actually correct. So I'm going to update the interactable script and remove an R there. And then in our interaction area 2D, we'll just update that. So getting the names right, sorry about that. And we have to remove an R down here as well. And let's update these variable names as well. And that should be right about it. If you want to do it all at once, you could do a Control R and do a find and replace if you want to make it a little quicker. So we found a new area, we push it onto the array. And whenever we get a nearby interactable, we want to check if there's a selected interactable. If there's not, then we're going to change it. So if selected interactable is null, and then we want to set the interactable to the oldest one in the array. So since we're pushing on the back, we want the one in the front. So selected interactable is going to be equal to nearby interactables at position 0, should be the first one in the array. Now that's how we recognize them, but what about when we leave the area? Then we need to connect on ready, area entered, dot connect. Then on ready, we need area exited, dot connect to a new function, underscore on area exited. So we make that function down here. Function underscore on area exited area of type area 2D. So of course we're going to check if area is interactable. So if it's an interactable area that just left our detection area, then we're going to want to remove it from the nearby interactables. So we're going to say nearby interactables dot erase, and we give it the value, which is the area 2D. So the area parameter up here is what we're erasing from the array. And then we also want to check if it's the selected interactable so that it'll no longer be selected. But first, let's tell the selected interactable that we are exiting the interaction. So we'll say selected interactable, and let's create a new method. Let's say StopInteraction with the user, which is the interactor up here at the top. So we're going to stop the interaction with the interactor if one exists. And then we'll choose another selected interactable if one exists in the nearby interactables array. So if nearby interactables dot size is now greater than 0, then selected interactable is now equal to nearby interactables at position 0. So after we remove this one, we get the oldest one that is still in the nearby interactables array, and that becomes the new selected interactable. Okay, now we need to add the stop interaction method to the interactable script. So let's copy paste this bit over here into interactable.gd. So function, I'm going to control paste. So instead of calling it the interactor here, I'll call it the user and node 2D. And we'll say push warning not implemented. So basically what we're saying is we do want every interactable script to have an implementation of this as well. And so we'll warn the developer that this has not been done yet. So on the fan scene, fan interactable area 2D, let's go into here. And for function stop interaction, which takes a user node 2D, I'm actually just going to have it pass. The reason for this is that when we interact with this fan, it's actually just going to be a one-time thing. It's not like the shop where we're going to have a user interface open for an extended period of time. So there's nothing actually to stop here. Once this value is set, our interaction with the fan is already essentially done. So we don't really need an implementation for stop. Okay, so after that, let's just make sure that we're extending from interactable with 1R since I changed the class name. Inside of the fan interactable script, I also want to add in one thing here. It's going to be a PrintDebug message. So I'll say fan toggled as the message, and that'll get output to the output console down here when we're in game and we press the interaction key. So let's go to the 2D level now. We have the player, which should have the interaction script, and the fan, which has the interactable. So now I'll run the scene. Let's move this up a bit. I'll go over to the area over here, and I'm going to press F to interact with this object over here. So you can see down here that I have the fan toggled message coming from the interactable fan script and the interact method. So we know that the F key is working from our player. We're telling the fan that our player toggled the button for the fan on, and now we can respond to that message however we want. So in the fan script, we want this to toggle the animations for the fan. Now, I haven't added the animations yet, so let's do that real quick. On fan, I'm going to add a child node, animation player, and I'll create two new animations, on and off. So animation off, let's click on the sprite 2D, and we will assign the texture here as the keyframe value for this animation. So I'm going to click on keyframe and create that. So when our animation off starts, that's our animation. This should loop technically, if we ever add extra frames to this, but this is just a one frame here. So that is pretty much all we need for now. Aside from that, we want to take animation H frames and make sure this is set to 1. So I'm going to keyframe this, create. This means that our sprite sheet here only has one column and one row, which basically 1 times 1 means we have one sprite image here. So let's create the on animation. Okay, on. And we're going to change the texture here. So let's say on, and I'm going to look for the fan. So I'll drag this into here. We can see that this is 4 frames. So we need to take H frames to 4 and then keyframe this. So that gets added to our animations sheet. And we also want to keyframe the texture to here. Then we need to go through the frames here. So on 0 seconds, we want the first frame. And then 0.05 seconds after that, we have the second, and then the third and the fourth. So let's take the snap and make that 0.05 seconds. So we have 20 frames of animation per second, basically. And let's keyframe frame 0 and create it. So this will automatically increment to frame 1 now. We add that in, add that in, add that in, and now we should have all the frames of animation. in this little animation window. So this is a 0.2 second animation. So let's change the time to 0.2 and toggle looping on, and we hit play. And that is our animation in theory. Yep, okay, so that looks correct. All right, now our fan interactable area. Let's jump into that, and I'll pause the animation for right now. So when we toggle this on, we need to change the animation in the animation player. So let's do @export var animation player, which is of type animation player. We can click on the fan interactable area and assign the animation player. So whenever we toggle is on to true, we want to play the on animation, and whenever it's off, we want to play the off animation. So I like to, whenever I have a string value that's going to be set for animations and stuff like that, I want to create a variable so that we don't hard code the string necessarily. So let's add an @export var, and let's say on animation, or on _anim, and let's say on, and then @export var off anim, which will be off. And I could give this a category, @export group, and I'll say animation names, and hit save. So this export group puts these variables under a category here, animation names. So we have on animation and off animation. And if you ever need to customize what animation names you're setting here, then you can change the strings here instead of inside your script. And you want to make that match your animation names here. So what we want to do in this script is whenever the isOn field is set, we want to call a setter function to make the animation player play the correct animation. So you can add a setter to isOn, basically treating it like a property instead of just a field, and we'll do set value. So let me zoom in a bit here. You have the colon, and then after that comes the setter and getters. So when you're doing a setter, you have the parameter here of value. So we're going to set the field's value to the new value we passed in. So first off, I'm going to check if they're already equal, and then we can just skip the rest of the code. So if isOn equals value, then we'll just return. Otherwise, isOn equals value. And since we changed the value, we want to change the animation playing on the animation player. So if isOn, then we're going to tell the animation player to play the on animation. So that's just this name right here. Oh, and I guess you could specify that these are string names if you want. The difference between a string and a string name is generally a string name is not changed during code. So if this is kind of something that's meant to be static and just persists through the whole game, you're not changing this string, then a string name can make sense. It's not necessary. I think automatically it converts between the two types. But I like to be a little bit more specific about what the intent is. So we're playing the on animation. So obviously, if it's not on, it's off. So we're going to say animation player.play the off animation. Okay, and I forgot to assign the animation player. So in the fan scene, make sure interactable area here, animation player. So whenever the isOn value is set, we want to update the animation player and tell it to play, and we want to tell it to play these animations down here. So what we can do is we can create a setter for, this isOn variable. And we would do that, let me zoom in here, by doing colon, and we'll say set value. So this is a setter, and we pass in the value. So first I want to skip this setter if the value is already set to this, because we don't want to update anything if the value is the same. So say if isOn equals value, then we return. Otherwise we say isOn equals value. So the setter needs to set the variable here. And the advantage of having a setter like this is that we can have stuff update whenever the setter is called. So whenever we set the value here, we can do other things. So first off, it's possible that the animation player hasn't been set up yet the first time the setter function runs. So I believe the setter runs at the start of the script, and the animation player may or may not be set up yet. So to get around that, we'll have the animation player's animation set the first time on ready. But let's say if animation player does not equal null, then we'll check what isOn is set to. So if isOn, and then we're going to say animation player dot play the on animation. And then if isOn is set to false, so else, then we'll say animation player dot play off animation. And we could actually pull this out to a new function. So I'm going to cut that, and let's go to the bottom, and I'll say function underscore to make it private, update animations, and we'll just paste that in there. And then instead of having all this code up there, we'll just put this in. update animations. So when the animation player changes, we'll just immediately have it update its animation to this value. So we'll have a setter here too, I suppose. So set value, and then we'll say animation player equals the value, and then we'll update the animations as well. So whenever you have a setter, the setter function will run once at the start of your script for these export variables, as it takes the values you set in the field here and assigns it basically inside the script, and then this code will run. So I think I can get away with this for the initial animation. So here's where we change it whenever isOn changes, and then here's when the animation player is loaded properly, it'll update for the first time. There's other ways you can do that. I think this will be a decent option though. So let's hit play and see if isOn is set to true when we run the scene. So let's run the gameplay scene and we'll see if isOn is true initially, and we can see the animation player is actually playing the on animation. So if I go to the script over here and I take isOn and toggle that off, then you'll see that the animation actually stops here. So whenever we set this property, the animation is going to update. And that's basically one example of why you would use a setter, so that you can have code run when a variable is set. Okay, I can move one tab there, just for clarity. Oh, and of course, we'll want to go into the gameplay mode and see if we can turn it off. So our player's over here, we hit F, and it stops. We can move the window a little bit and see fan toggled on, and we can see fan toggled off. If we hit F again, it's toggled on. F to toggle it off. Some weird sprite thing happened there, and F toggle it on and off. And we can see what happened with the animation, but clearly setting it as on and off is working. So let's check the fan scene real quick. An animation player. So we have animation on, let's do animation off. So what was going on here with the animations is that on the off animation, we don't set the frame keyframe. So if on our on animation, we happen to be on frame 3 or 4, but the off animation only has a single frame, then what's going to happen is that it's trying to show a frame that doesn't exist. So we need to make sure H frame is set to 0, and then we need to make sure on the Sprite 2D node that the frame is keyframed at frame 0 here for this first one here. And we need to kind of make sure we have all three of those values set for any future animations as well, as long as we're animating these properties for our animations on the object. But if we hit play now, and let's go over here, let's toggle it on, toggle it off, and then on, off and on, you can see that it works just fine now. So we can turn the fan on and off. Okay, so now let's work on the shop frog. So we're going to have an interactable area just like before. That's going to trigger the shop UI to show. And of course, we'll have the shop hidden by default eventually. So let's add an area 2D to start. I will right click here, add, and we can actually search for Interactable, and we can grab the Interactable script right here for an area 2D. So if we click on the script here, we can see we already have the Interactable script attached. Now, we can't use the base class for it because these functions haven't been implemented, so we'll just get a bunch of warning messages. So what we can do now is right click here, and I'm going to extend the script. So this means we're already extending from Interactable, and we want to take that and in character shops, I suppose, we'll make it something like open shop interactable.gd, and that'll kind of be our class name as well if we want to set a class name. So you don't actually have to give a class name to all of your scripts. As long as you can remember where they're stored, you can just drag and drop them onto the node that needs it. But if you want to be able to create it from the menu, then you would want to have something like class name open shop interactable. Then you can hit save there. And once that's green, you'll be able to search for, as you can see, open shop interactable. So up to you if you want them to flood the menu like this with a bunch of extra options that you can easily reference, or if you just want to search your project for the script and put it on the node that needs it. So for this project, I guess, just in case you need it, I'll go up here to the top of fan interactable, and I'll say class name fan interactable. So if you have any need for these scripts or you want to reuse them, having a class name makes it a little bit more reusable in a sense. Okay, so our open shop interactable, we want to implement those two functions. So I'm going to right click on interactable here, lookup symbol, and let's grab these two functions. And I'm going to go back to open shop interactable, and let's just paste these in here. So these are kind of like our minimum requirements for things we need to add. So when we interact with the shop, we want to make sure it's open, and when we stop the interaction, we want to automatically close the shop. So let's have a reference to the shop UI. So we'll do @export var shop UI, and that's going to be a control node. So basically any UI element we can assign in the inspector. If we click on Interactable, which I'll rename now because it's an open shop interactable, so we'll call it open shop interactable, matching the class name. Then we can assign the shop UI. So I hit assign and we hit shop UI. So when the user interacts with the shop, we're going to open the shop. So let's see, shop_UI dot show. And then when we stop the interaction, we hide the shop. So shop UI dot hide. Okay, now before we can test this script, we need to add a collision shape 2D to our area 2D. So add a child node, collision shape 2D. We'll make it a circle, and I'll make it a little bit bigger here. We can also make it a rectangle if that fits our shape a little bit better. So maybe I'll change that to a rectangle. And let's just fit the space where we can see sprites visible. Oh, maybe just the frog and the stand he's on. Yeah, okay, sure, that works. All right, so when the user interacts with the shop, we'll show and then hide. So the first step of testing that is going to be to hide it initially. So I'm going to hit hide here on the shop. Let's hit play. Let's go up to the shop. I'm going to hit F. Okay, it didn't actually work. So let's find out why that didn't. Okay, so we can actually see in the console. When we were interacting, it was interacting with the fan, not the shop. So what I think I want to do is give ourselves like a visual indicator. So when we're trying to interact with an object, let's put a little sprite over that object in order to show that this is the object which we're trying to interact with. So I'm going to create a little indicator scene. So let's make this a 2D scene. I'll say interact indicator. And let's give it a sprite 2D. So sprite 2D. And then let's see if there's any art from the Pixel Adventure pack. This is CC0, by the way. And I did put the license details down here for that. So let's make the indicator a pineapple, because why not? Well, there's a whole animation for this. Okay, yeah, sure, we can add an animation player. I'll right-click on the indicator and do add child animation player. And then with that, we'll create a new animation. I'll just call it a loop. We will make it loop, of course. And then we click on the sprite 2D, and let's go to animation. And we will set the number of H frames and then keyframe it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I believe there's 17 frames in here. So let's do 17. That looks about right. We'll keyframe the texture as well. And then I'll hit this 17 times after I change this snapping. So 0.05 for the snap. And I'll do 1, 2, 3. Basically, I just need to do this until we get a dash between the two frames. So I'll just click this a bunch of times. Okay, and there you see our dashes. The dash means that the value didn't change between keyframes, so we just get rid of these last two. And then we need to stop it here at 0.85 seconds. So loop stops at 0.85. 0.85. And let's hit play. So that is basically our animation for the pineapple. But I want to go one step further and just make it a little bit more animated. So I'll start at frame 0. And let's go to the sprite 2D. And we'll look for transform, scale. Scale's right here. So let's keyframe scale there. And then at the end, we'll keyframe it again at value 1.0. And let's go halfway in between and say something like 1.25 and keyframe it. Okay, now if we hit play, it's going to just have a little bit of a animation there where our pineapple's getting bigger. So it should be really easy to catch it when it's actually over something in the scene. Okay, so let's save this as, I'll say UI, and I'll make a folder indicators, I guess. And then we'll have interact indicator.tsc and save it. So what I'm going to do now is for the interaction area, whenever we change the selected interactable in the script, we're going to put that indicator over it. So let's jump into the script. And then at the top, we're going to need another export variable. So I'll say export var indicator scene, which is of type packed scene. So a packed scene can be instantiated. You can create copies of it anywhere you need. So what I want to do with this indicator is whenever the selected interactable is sent, I want to take this packed scene and I'm going to move it to the interactable if it exists. If it doesn't, then I'll instantiate a new one. So let's do a set value. If the selected interactable is the value, we'll just return, skip the code. Otherwise, selected interactable equals the value. And up here, we need to instantiate a copy of the indicator scene. So we'll have a variable to store that indicator. Interaction indicator is a node, or a node 2D, I guess, because it does exist in the game world. And so if interaction indicator is null, then we'll instantiate a copy of this packed scene. So interaction indicator equals indicator scene.instantiate. So we create a copy of the scene we just created. That means this interaction scene, we're spawning that into the game world. And then we assign it to this variable. So now we need to add it as a child to whatever the selected interactable is. And for that, we need to move this actually down here below. So we know the new selected interactable. Okay, and so we'll say if selected interactable does not equal null, then we're going to assign it to that space. But we only want to do this also if the selected interactable is also not null. So we only attach a indicator if the interactable exists. So if selected interactable is null, then we'll just return and skip this other code. Let's also pull this out to a new method. So I'll call it something like add indicator to interactable, and we'll pass in the selected interactable. Okay, I gotta spell check that right there. Okay, now I'm gonna cut this, and we're gonna create this function at the bottom. So at the bottom, add indicator to interactable. Add indicator to interactable, and we need to know the interactable, which is of type interactable. So we create the indicator if it doesn't exist, and then we add it as a child to the interactable. So interactable.addChild, and we'll say interaction indicator. But this will basically be if we go in here. If it already has a parent, then I think what you actually need to call is, let's see, interaction indicator.reparent to the interactable. So I think you can only call the add child function if it hasn't had a parent assigned already. So that makes sense when we're instantiating it, but not when we're reparenting it. So we would want a else, and then else we're going to reparent it. Okay, last thing, if our selected interactable is null, then we'd have nowhere for the indicator to go. So we're going to free it. So interaction indicator, I'll say .queue_free, which, if I remember right, is basically at the end of the frame, it cleans it up. Okay, so if that's working right, we'll get our indicator and we'll be able to see where we're actually interacting with. Okay, so let's see, cannot call instantiate on a null value. Yep, right. So in the player scene, I need to assign the indicator scene. So let's assign this from our project, quick load, and then we have the interact indicator. So we open that, that's our packed scene. We can click here and hit open scene to see it. So that's what we're going to be spawning whenever we call instantiate. Now let's go over here, and there we can see our pineapple. But it's really not in the right position, so maybe we have to offset that a bit, and we also need to tell the animation to autoplay. So let's go to animation player. I'm going to tick autoplay right here. So this animation player will always be starting with this animation. Okay, and then in interaction area, let's create a variable for the offset y. So indicator y offset, which will be a float, and I believe we want to go up, so that's going to be negative value. By default, let's say negative 40.0 pixels. And then we go down here. After we reparent it, we want to set its position relative to the interactable's position. So interaction indicator dot global position equals, okay, so for this global position, we need the X and the Y position from the interactable. So I'm going to be putting a vector2 here, open up the parentheses, and I'll hit enter to put this on 2 lines. So the X will just use the X position, interactable dot global position dot x, and then comma, now we need the y value. So we'll say interactable dot global position dot y, and then we add the offset, so we'll say plus offset, and then we can grab property indicator y offset. So add that in. Okay, and that should help us set the position of it. So let's hit play, and we'll go over to the thing, and there's our indicator for what we're interacting with. If I go over here, we can see that the leaving of the area is not working, and I can kind of prove that if we exit and we go to debug visible collision shapes. So now if we hit play, we should be able to see exactly what's going on here. So when we get here, we've entered the interactable area, but if we leave, it's no longer being removed there. And also when we come over here, it's not changing to this one. So let's close that and we'll go to the interactable area script. I'll set a debugger point right here. I'll hit play, and then we'll see if it actually is able to leave. So we leave the area. Okay, so we triggered the breakpoint. Let me kind of go through this. So we have our interactable nearbys. So that should get erased if we go to the next step. So next step, and it was erased from the dictionary. And then we're going to have selected interactable stop interaction. We could jump into that and we can see that that's just going to pass on the stop interaction. So let's continue. And then if the nearby interactables.size is greater than 0, then we change the selected interactable. Yeah, the problem here is that we need an else. So if there is nothing in the array, then we have to set it to null. So else selected interactable, it's going to be equal to not false, but null. So an object is null when it does not exist, or it's not set to that variable. Okay, I'm going to drop the breakpoint. Let's hit play, and then let's go over here, and we leave the area, and now you can see it's working properly. Okay, if we go over here and we get to the second interactable area, so we kind of enter here, but I leave the area, you can see that this is trying to queue free on a null. We saw that it disappeared after the first area was left, but the indicator didn't come back. So kind of a tricky bug here. When we exit this area, it disappears, but then the new one doesn't spawn. The reason for this actually happening is because queue free waits, I think, till like the end of the frame in order to free this. So it's actually already been assigned to this node before it gets freed. So it disappears after it gets assigned, which is a problem for us. So what we want to do actually is just free immediately on this interaction indicator. So that'll mean that as soon as we leave this area, if there's no indicator to attach it to, then it'll be freed. And then we get over here and a new one gets created. So I think that's just better for this specific edge case. Okay, and that kind of fixes our problem there. One other thing I'm going to do is expand this area 2D, and whenever we have two interactables in the same area, I'll just say that whatever the closest one is the one that we're going to be using, instead of the one that's currently selected until we leave that area. That'll just mean that it'll be a little bit more reactive, and we'll always be interacting with the closest object. So for that, we'll need to use a process function. So basically on every frame, we can update whatever the selected area is going to be. So let's say here that if nearby interactables dot size is greater than 0, then for interactable in nearby interactables, so we'll loop through all of them and we'll check the distance. Right before that, let's have a couple of variables. Variable closest distance, which is a float, and then we'll have variable closest interactable, which of course is an interactable. So basically we calculate the distance between our interactable user and then the target interactable position, and whichever one has the closest distance we set to the selected interactable. So we can take this and default it to INF for infinite, and let's get the distance. So var distance to interactable is equal to our interactor dot global position dot distance to the interactable dot global position. Now that we have that, we check if it's less than the closest distance. So if distance to interactable is less than the closest distance, then closest distance equals distance to interactable, and the closest interactable is the interactable. Once we're done with all that, we'll say the selected interactable is equal to the closest interactable. And we can basically take all this out and just put it in a function. It doesn't need to just be straight in the process. So let's create that at the bottom. And I'll call this something like set selected interactable to closest. Then we take all this code, we put it down here, and I'll call this function in the process instead. Then this little comment describing the function, that can actually go here. I'll add an extra hashtag to make this markdown code. And that should be basically all we need to do to clean that up. So to test if that works, let's go to the player, and we're going to take our collision shape area for the interaction area, and I'll make this bigger. Also rename this to be like interaction shape, so that if we hover over it, we can see the name of it, and it's very clear. So on our level, we can see that this is now a much bigger region, and it will be able to easily cover these two. And we'll leave debug visible collision shapes on. Now let's hit play, and we can see, of course, that's not working. Okay, just checking here in the interaction area that the interactor is still assigned. Okay, and now we should be able to hit play and see if we can get that to work. Okay, so let's see, vector2 and float and operator. Oh, yeah, I just put direction2, I meant distance2. Okay, and let's refresh that, let's run the scene. And now let's get closer to the second target, and we can see our indicator jumped over there. So this is now the one we're interacting with, and this is now not the one we're interacting with. So if I press F here, it's going to stop the fan, and I go over here and I press F, and it opens the shop. So here opens the fan, here opens the shop. Now really that should be toggling the shop on and off. If we press F on the shop again, we want it to close, like we would if we hit the button. So we can fix that really quick on the open shop interactable. We'll say if shop UI visible. So say if the shop UI is visible, then we're going to hide it. So I'll copy this down to here. Else, we're going to show it. Okay, and that should allow us to toggle it on with interact. So we go over here, on, off, on, off. And we can, of course, close it with this. So our interactions are basically good now. But when we open the shop, we want to set the player into the shop UI so that we can actually see the player's name and how much money the player has. So in shop UI, I'm going to attach a script here. Let's create a new shop UI script. So I'll just save it as shopui.gd. If you want, give it a class name. So inside of the shop script, we're going to want a var for the user, and we could say this is any node2d. We'll get rid of the ready and process functions. So in our shop, we have a label for the user. So when we have the user set in the shop UI, let's update the label. So I have an @export var user label, which is a label. If I save it, I can assign it in the inspector now. And also rename that user label. I think that's a little bit more clear. And money label. Okay, so when we assign the user, let's do set value. The user is going to become the value. And we'll say if user does not equal null, then we'll say that the user label dot text is going to be equal to, and let's say user colon add a space and then plus user dot name. So this will be the name of the node. Okay, now on our shop frog, the open shop interactable, we want to set the user in the shop. So inside of here, we'll say shop UI dot user is going to be equal to the user right here. And in this case, when we hide it, we want shop UI dot user is equal to null. And I'm going to copy and paste that down here as well. So when we hide the shop, there's no user in the shop. And when we show the shop, we want the user to be the user we just passed in for the interact. So let's hit play and run it. I'll go over here. Let's hit F. And there we have the user of the shop is the player. Now we need to get the money from the player's inventory. Now currently you can see our player does not have a inventory script attached to it. So let's add one real quick. I'm going to right click, add a child node. We'll do a node here. I'm going to rename this to be inventory. And this is going to be super basic. It's just only going to store the money basically. But let's right click here. I'll attach a script. So player inventory. I'll put it one directory up because maybe the characters, like an NPC has an inventory too. But I'll just leave this as inventory.gd, lowercase I, create. And this is going to have a @export var money field, which is an integer and will default to 0. So we want to find the inventory node from the user of the shop. So let's go to the shop UI script. And the player script should be 1y, not 2. Player.gd. I've been making all kinds of typos today. So let's go into the shop UI. When we set the user, we're also going to get the inventory from the user node. So let's say var user inventory is going to be of type inventory. Okay, and we need to make sure that inventory script has a class name so we can reference it. So class name inventory, save that. Now in the shop UI, we should be able to assign the class type right here. So when we set the user, if the user is not null, then we also want to try to get the user's inventory. So we'll say var found inventory, which is of type inventory. It's going to be equal to, let's say, find children. And then I want to set the type parameter here. So we're going to do quotes for the first one, and then we're going to do quotation inventory for the second one. So we're going to get an array of nodes that have the inventory class matched. And we want just the first one we find, I guess. So that should work here. This will either be null or the first inventory node we find in the list that we're searching in here. So user inventory is going to be the found inventory. And actually, we can just skip a line. Let's just say user inventory equals find children inventory first in the array. Now, if the user is null, we want to erase the reference to the inventory. So else user inventory is null. Now, when we get the inventory, we can set the money label. So let's do a export var money label, which is of type label. Now in the shop UI, we can assign the money label. And then when we set the user inventory, if the user inventory isn't null, then we'll also update the money label. So let's have a setter here as well, set value. And we can say user inventory is equal to the value. And we'll say if user inventory does not equal null, then money label is going to be equal to money colon plus, let's say, user inventory dot money. So we just get the property value right there. We do need to convert it to a string, so put string str and wrap what we're converting, the integer here, into the string value. Okay, yeah, so it says we can't assign a string to a label. We need to do money label.text. Otherwise, if there's no inventory, we want to change the text too. So we'll say money label.text is money colon, and we'll say n/a not available, not found, something like that. Okay, let's hit play and we'll run it. So we'll go over here. I'm going to hit F, and we'll see that we did not find the inventory on the user. So this gave us an error. If we do a find children in this no array that comes back, then this can error out. So let's say for child in, and we'll say find inventory here. So for each child, we'll loop through the array that this returns if there is one. We'll say if child is inventory, so we're actually specifying the class name here, then the user inventory is equal to the child. And let's hit play and see if that works. So we'll come over here, I'll hit F, and we don't find the inventory, we don't set the money here. I'll set a debug point here to see if that's actually hitting at all. We'll go over here, I'll hit F, and this time it just says not available. So if I hit F a couple more times, it's not finding the inventory. So our inventory script, I think, is called the same. So let's just paste that in there and make sure. Okay, there's a couple extra parameters here. So we have recursive, we want that to be true, and then owned, we want that to be true as well. Owned means it's not an orphan node, it's actually attached to one of the parent objects in the scene. So let's see if that changes anything. I'll go over here, we'll hit F, and it's still not working. So I figured out why. It's because we're not using the user node here. When we say find children, we mean the shop UI. So of course the shop doesn't have the user. So we need to do user.findChildren. And that should work for us. Okay, let's hit play. Let's go back over there. I'll hit F. Okay, now we actually find the inventory. So hit play, and then you can see money 0. So we set the user, and then the shop UI looked through the user's child nodes to find the inventory, and we grabbed the money field from the inventory, which is set to 0, and we set that here. So that's all the basic direct interactions using areas between our objects in the scene. But there's a few more problems though. First off, this label debug, which this label up here in the top left, which is existing in the gameplay scene. If I close the scene now, you can see in my gameplay scene, the main scene that loads up when the project starts, when you run the game, that the money label is separate from the level here. So what if you load up a different level that has a different player, and basically you have no direct reference from an export field to the character inside of the level? Right now I could right click here and do editable children, and then I can grab the player node, but then I have to expose all of these other subnodes as well, which is a little bit cluttered. But also I might load a level during the gameplay that isn't set in the editor. So one good way to share data between objects without requiring them to be set in an export field in the same scene is to use a resource object that goes between them in order to communicate data. So I'll create a new folder in my project for that. I'll right click, create new, I'll just call it data, I suppose. And here I'll right click, create new, and let's do a script. So I'm going to call this playerdata.gd, and this will inherit from resource. So the advantage of resources, well, one of them, is that they can be saved to the file system and loaded from the file system or other save files or locations on your computer. They don't have to be saved and referenced within the scene itself. So because it's a saved object that exists in the project's file system, just like you would with a sprite texture file, you can assign it to any scene, multiple scenes if you want, which means that objects that don't exist on the same scene can actually share data with each other. So it's like a shared resource. Let's create. So for the script, let's go into here, and I'll give it a class name, and this is going to be player data. Now I'm going to right click here, and let's create a new resource. I'll look for the player data type. So we just created that. And I'll say player one data, I guess. So generally, I mean, most people probably just going to be making single player games, so you're only going to need one player data. And we'll just keep it simple for that. So like when we're talking about the player one data, we're just talking about the person playing the game, the player character. Okay, so what data do we want to share between our player and the money label? Well, we want a reference to the currently active player. So let's say @export var player, and this will be of type player. Now, here you can see there's no player class. I might have not set a class name at the top of the player script, so let's do that right now. Class name player. Okay, so inside of here, what are we going to want? We want a reference to the current player. So this is going to be set during gameplay by the player. So I'll say var, and this will be player of type player. And then we're also going to want var, not player inventory, we'll say var inventory of type inventory. The player inventory is redundant because we already know this is a player data class. So we already know this is the inventory for the player. Okay. Now on the player script, let's attach the resource. So here we'll do @export var player data of type player data. Now let's go into the player scene, click on the root node, and we assign the resource here. So I'm going to drag player one data into here. And now when the player loads, we can set the inventory and we can set the player inside of this, and then other objects will be able to respond to that. So let's do @export var inventory of type inventory. I'll assign the inventory in the inspector. Okay, and then on ready, we're going to set the player and the inventory in player data. So we need a on ready function. So function underscore ready. Then we're going to do player data dot player equals self, and we're player data dot inventory equals inventory. Okay. So as soon as the script loads, the data is set in the resource. So next we need to set the resource in anything that needs to read from it. So let's go to gameplay, money label here. I'm going to attach a new script here. So this will go under the UI folder. I'll say money label.gd, open, create, and let's add a export for the resource file. @export var player data, and I'm going to drag this in here. So we could try to do something like on ready, we just set the money labels text to the player data's resource. But I think a better way of doing it, rather than directly setting the values, would be to use signals. So in player data, let's look let's look up the symbol, and then we can set it here. Let's just create a couple of signals so that whenever the player is set or changed, we emit that a new player has been set. And whenever the inventory changes as well, we can respond to that as well. So let's do signal player changed, and we'll say new player, player, old player, player. We'll also have signal inventory changed, new inventory, inventory, old inventory, inventory. Okay, then on our setters for the player and inventory, let's create those right now. Set value. So if player equals value, we're just going to return and skip the code. Otherwise, player equals value. But before that, we'll have var last player equals player. So that means we can pass the new player and the last player into the player changed signal. So player changed dot emit player last player. Okay, now this is going to be a lot more reactive. So whenever we set the player here, we have these signals being emitted, and anything that needs to know about there being a new player set on the player data can connect to the signal and receive data whenever the player changes. So we'll do this exact same thing for inventory down here. So we'll do set value. If inventory equals value, then we return. Otherwise, var last inventory equals inventory. And we'll say inventory equals value, the value passed into the setter. And then inventory changed dot emit. And we have inventory, comma, last inventory. All right, so now instead of reading these values directly, we're going to read the data from the signals. So in money label, let's connect to the inventory changed signal. So player data dot inventory changed plus, and we're going to say dot connect underscore on player inventory changed. Or I guess player data inventory changed, if you want to be a little more specific. Okay, so now we write that function. And of course we need the same parameters. So new inventory of type inventory and old inventory of type inventory. So I know we're not going to use the old inventory, so we want to give it an underscore to indicate we're not bothering with it. It doesn't really do anything for us. But what we're going to do is we're going to take the money labels text and we're going to set it to the money value from the new inventory. So text equals money colon plus new inventory dot money. Okay, and we have to do a string for this. Okay, and that should be about right. Okay, so we have a resource here. The player has its resource. So let's hit play and see if it actually sets up here. So let's hit play and see if that works for us. So we can see the money is not actually updating here. I think the reason is because the player is loading before the rest of the gameplay here. So just in case for the ready script on the player, let's do call deferred to make this code run a little bit later. And we'll call the function name here underscore update player data. Okay, and then I'm going to cut this down to the bottom. And we'll have function underscore update player data. And yeah, basically just pasting in what we did there, setting the player, setting the inventory. Now it's just this is going to wait till the end of the frame. So in the case of the gameplay, everything loading at the same time, we actually wait till everything's loaded before we set the player data. Now if we hit play, on the top left we have our money updated there properly. So we just waited for the label to be there before we set the values. And that's probably a good idea. Okay, so our shop can read the money and we have the money up here. But what if the money actually changes? So in our gameplay UI, let's add a button. So I'll add a button to the HUD, and let's say increase money button. I'll attach a script to it. Increase, let's save it in the UI as increase money button.gd. So what are we going to be increasing? The player's money. So at export var player data, we'll use it here too, player data. And how much do we want to increase it by? At export var amount, and let's just say equals 5, so integer is implied. So whenever we press the button, it's going to increase the money by 5. Now, to make sure that happens, we'll connect to the button signal. So pressed.connect, and we'll give it the function name underscore on pressed. Give it this process bit. We don't need this. Function underscore on pressed. And we'll say player data dot inventory.money plus equals the amount. So we need to assign the player data. So I'm just going to drag that in here. You can also click here and do quick load and find the player data resource. There's only one in the project, so very easy to find. Okay, now we just need to position this somewhere in the scene that makes sense. So I'll put it down here. Let's expand it, make it big enough. I'll give it the text, add 5 money. Maybe I'll get a little better there. Sure. Let's hit play. Okay, we have our button. I'm going to press add 5 money. Nothing visually happened. If I go over to the shop, you can see the shop knows it's 5 money because the shop read the value of the money after the money had been added. If I keep pressing add money, you can see that the value doesn't update. If I hit F twice, now the value is read again, so it updates the money in the shop. So what we need is another signal whenever the money changes. Basically, the inventory is updated. We let other objects like the shop and the money label here respond to that. Okay, and I think this will probably be the last step for this tutorial. So let's go into the inventory script, and I'm going to add in a signal, and we'll say money changed, and we'll say new value, and oh, we don't really need to say new value. We'll just say new and old and. Okay, that should be clear enough. So we'll just have a setter on our money property, set value. If money equals value, nothing's changed, so we can just return. Or money is equal to the value, and we'll need a reference to the last value. So var last money is equal to money. Just like before, we pass both of these into the signal. Money changed dot emit, and we want money and comma last money. Okay, now we just need to connect to these signals from the shop UI and the label. So for the money label, so inside of here, whenever the inventory changes, we also want to disconnect from the old inventory's money signal and add a connection to the new inventory's money signal. So if old inventory is not null, then we'll disconnect. So now we can get rid of this underscore here because we actually are using the old inventory. So say old inventory dot money changed, and we're going to disconnect from that signal. And we're disconnecting the underscore player data, or let's say player inventory money changed, I guess is a good name for it. Okay, so we need to create that function now. Function underscore player inventory money changed. So of course we have the new, which is an int, and the old, which is a int. So we only care about the new here. So let's underscore the old, and then we set the money here to this new value. So our money is the new value that we receive from the signal. Now we haven't connected to that signal yet, so we want new inventory dot money changed signal dot connect, and we pass in this callable function name. Bam, just like that. Okay, now if we hit play, we should have a reactive UI. So I hit 5, add 5 money, and you can see it keeps track of our money up here. Now we didn't assign the inventory in the inspector. We assigned the resource, which is that intermediary object sharing data between the things that need it. A UI that might exist in a totally separate scene before everything gets combined in our gameplay scene, and the player's inventory and data. So hopefully you can see how this kind of pattern of using resources as an intermediary sort of event bus style pattern is super nice once you figure out how signals all work. So we still need to set it up for the shop. If I have the shop open, you'll see that it's not responding. So now in the shop UI, we almost are going to have the same type of code as the money label here, except we're not always showing the player data. We want to use the user of the shop's inventory in order to reflect how much money it has. So in shop UI, when we set the user inventory, we want to connect to the money signal on the inventory. So first off, we're going to check if user inventory currently is not null. Then we want to disconnect from its money changed signal. So user inventory dot money changed dot disconnect, and that's going to be underscore on user inventory money changed, I guess is an okay name for it. We'll create that function down here. Function underscore on user inventory money changed, and we're going to have the new money and the old money. which we really don't need, so that's going to be an underscore variable. For right now, we'll pass. And then when we set a new value, as in right here, we'll say user inventory dot money changed dot connect, and we just put in the function name here. So when the inventory is set, we connect to the money changed signal. And when the money is changed here, then we're going to take the money label and set as text. Money label dot text is going to be equal to money, and we want the new value. So you can see here that I'm using this string here, money, for like the prefix on how we display the money label. So we could actually have a export var here at the top, and we'll say money label, money text prefix, I guess we'll call it. So how do we want it to be represented? I'll just make it this string here, put it up here. And now I'm going to use this in place of here and here and here. And then I'll do plus quotation marks not available. So that just cleans it up a little bit. Let's hit play and let's see if this is actually going to work. So we have our money, we hit it twice, we have 10 money in the inventory, so that's communicating through the player data. This is player data right here. Now over here for the shop, we open it up, and this is reading directly from the user, which is the player, grabbing its inventory, and we connect to the signals on that inventory. So if I add 5 money, well, it did trigger this, but I messed it up. And that's because we need to wrap the integer of the money in a string. So string new. We do that, hit play, and it looks like it's going to work correctly. So I'll go over here, we add 5 money, and now you can see that we are actually tracking the money in the shop and the money label up here. But the way we're doing it is differently. Top left, resources, we connect to the resource, and here we're referencing the user of the shop, which is dynamically chosen during the gameplay using the interactor and the interactable script. So from here, you would probably do stuff like have an inventory, and then you're subtracting the money from the player, add the item to the inventory. So obviously your inventory would have like an add and remove function for items in the inventory. And that should be pretty clear there. If you have other things like a chest, it would kind of be the same thing. Like you go up to it, you press the interact action, and then you can have the chest play its open animation, and you can take all the items out of the chest. Maybe they spawn into the game world, and then you pick up the pickup items. Or they just directly get added into the player's inventory. Or it could also be popping up a UI like this, where you can drag the items from the UI into the player's inventory. Of course, that would mean creating more additional UI elements. But hopefully this video has given you guys a really good introduction to how you can have your player interact with objects in the game world and sharing data between them, both using the direct connection of a Area 2D, an interactable Area 2D, and then also sharing data between different relevant nodes using a resource so that you don't directly need to connect a player to your UI or that kind of thing. You just need to have a shared resource that they all take data from and can connect to signals on that resource. I hope that you guys learned a lot. Consider checking out my Ko-Fi/Patreon pages if you want to support the channel. Thanks for watching. I've been Chris, and hopefully I'll see you guys in my future Godot video content.